Hello everyone. On this video we're going to be taking a look at how we can calculate the area of trapezoids. And so let's jump right in. First we need a definition, a key definition that comes into play when doing the area of a trapezoid, and it's the definition of something called the altitude of a trapezoid. And so the altitude of a trapezoid is a segment that is perpendicular to a base or a line that contains the base. Sometimes you will see that aspect of the definition of an altitude come into play. But for the most part, you're looking at a segment that's going to be perpendicular to one of the bases of a trapezoid coming from a point on the opposite base. So to kind of illustrate what we're talking about here, if you take a look at this diagram, you can see we have a trapezoid. And remember from the definition of a trapezoid that we learned a while back, it's going to have exactly one pair of parallel sides that are going to be called bases. So we might call this base 1 and that base 2, or B1 and B2. You see this segment right here is coming from one of the bases going to the opposite base, and it's perpendicular to that opposite base. It forms this 90-degree angle. So this is what we are talking about when we describe the altitude of a trapezoid. And since all bases of trapezoids are parallel, it would mean that all the altitudes of a trapezoid will be congruent. So in other words, if I picked another point on base 1 right here, and I dropped an altitude down to base 2, right? If I drew a segment that was from base 1 to base 2 and perpendicular to base 2, it's going to be congruent to this other altitude. No matter where I drew that segment somewhere inside this trapezoid, all those altitudes will be congruent. And we call the length of that altitude, we call that the height of the trapezoid. So the altitude and the height of a trapezoid are pretty much synonymous. You can use them pretty much interchangeably. So that takes us to the theorem that's going to give us a formula for the area of a trapezoid. And before I give you the area, I just want you to take a look at this trapezoid that I've drawn on this grid right here. What I'm going to do is I'm going to draw a duplicate trapezoid, one that's just like this, but flipped over and kind of attached to this trapezoid. And so what I mean is I'm going to take this trapezoid and I'm going to kind of rotate it over this way and draw it again right over here. So you can see this base is 3 units long. It covers 3 squares on my grid. So I'm going to draw a base right here that's 3 units long. This base down here is 1, 2, 3, 4, 5, 6, 7, 8 units long. So that base that's 8 units long will be right up here. So I have my 2 bases, and then of course if I connect those, if I connect the endpoints of those 2 bases, you can see that what I've done is I've just duplicated this trapezoid, kind of flipped over, kind of rotated it over, and put it right over here. Now, this new shape that I created is, of course, a parallelogram. These sides would be congruent, or I'm sorry, those sides would be parallel and congruent, and this side would be parallel and congruent to this side over here. I'm not going to go through the proof of why that would be, but you can trust me on that. Those would be parallel and congruent. And so if I think back to what I've already learned about the area of this parallelogram, it would be this measurement right here, or the base, times this measurement, or the height. Well, if we labeled base 1 and base 2 down here, of course this would also be base 2 and this would be base 1. So this measurement right down here is base 1 plus base 2. And this is, of course, the height of our trapezoid and of our parallelogram. So if I was finding the area of this parallelogram, I would take the height times base 1 plus base 2. And that would be the height of this entire parallelogram. So it would kind of make sense, since these 2 trapezoids here and here are identical to one another, if I wanted to know just the area of this trapezoid, right? So the area of the parallelogram we said was the height times base 1 plus base 2. That's the entire parallelogram. If I wanted to just know the area of this trapezoid, I would just take half of that area right there, half of the height times the base 1 plus the base 2. This turns out to be the formula for the area of any trapezoid. The area of a trapezoid will equal half of the product of the height and the sum of the bases. Or in other words, the way you're usually going to see it written is area will be equal to 1/2 height times base 1 plus base 2. And so if I was actually going to try and calculate the area of this trapezoid right here, I've already told you that base 1 we know is going to be 3 units, and base 2 is going to be 8 units. The height we can see here is 1, 2, 3, 4 units. So if I was calculating the area of this trapezoid, it would be 1/2 of 4 times 3 plus 8, which would be 1/2 of 4 times 11. Half of 4 times 11, well, half of 4 is 2, and then 2 times 11 would give us 22. So this trapezoid right here would have an area of 22 units. So that's really the basic idea behind area of trapezoids. It's this formula. It's kind of the longest formula we've looked at so far. It has 3 measurements that you need to know: the height of the trapezoid and each of the bases. But other than that, it's pretty simple. It does have the fraction thrown in there that sometimes can make it a little bit tricky, but it's really not too bad. Let's look at a couple of questions where using the area formula for a trapezoid is going to come into play. I have 2 different trapezoids right here, and we're going to find the area of each one. Now, what you're going to notice is on each one of these, I'm not given all the measurements that I'm going to need to use in the formula. I'm not given the height and both the bases. If I look at example A, I have this right here, which is going to be one of my bases. So I'll say that's base 1. But this measurement over here, that's base 2, right? I'll put a little B2. That's base 2. I'm going to need to know that. I also need to know the height of this trapezoid. And I kind of get lucky on this one because this is a trapezoid where one of the legs is this segment right here. Of course, it's a leg because it's not one of the bases that are parallel, right? But this leg is perpendicular to both bases. So that can serve as our height. It's a segment that's going from one base to the other base, and it's perpendicular. So it fits that definition of height of a trapezoid. So what I'm missing is base 2 right here. So let's figure out, how can I calculate what base 2 would be? What I'm going to have to do is I'm going to have to add in a segment. You're going to find yourself doing this a lot on the homework problems for section 3 here. I'm going to have to add in a segment right here. So I'm going to draw a segment in right there. That is going to be perpendicular to base 2. And of course, I can take this 20 for the height, and since all the heights or all the altitudes of a trapezoid will be congruent, and this would qualify as a height of the trapezoid, I can take that 20 and I can transfer it to right there. And so now what you can see is I got a right triangle right here where I know these two sides. So I can use the Pythagorean theorem to find this measurement right there. I also can take this 15 and I can transfer it across to the other side, because this shape right here is essentially a rectangle. And we know that the opposite sides of a rectangle are going to be congruent. So this 15 can go right over here. Now if I find this mystery measurement and I add it to 15, that's going to be my base 2. So let's start with that. Let's go ahead and call that x right there. And let's use the Pythagorean theorem. We'll say x squared plus 20 squared equals 25 squared, because of course that's across from the right angle, so it's got to be c in my a squared plus b squared equals c squared setup. So that's going to mean that x squared is equal to 25 squared minus 20 squared, which if you grabbed your calculator and you typed in 25 squared minus 20 squared, you should get an answer of 225. So if x squared is 225, that would mean that x is the square root of 225, and 225 is a perfect square. This is going to come out nice and neat as 15. So this part of base 2 is 15, but this part up here is also 15. So that means that base 2 is 15 plus 15, or 30. Now I have everything I need in my formula. 1/2 the height, which we said was 20, times base 1, which we said was 15, plus base 2, which we just figured out to be 30. So we're looking at half of 20 times 45. Half of 20 is 10. 10 times 45, that's going to give us an area of 450. Now example B is going to be a little bit trickier. You'll notice that what we have in example B is we have some angle measurements here. This looks like an isosceles trapezoid because here are the bases, And here are the legs that are each 4, so those legs are congruent. And we have base, we'll call that base 2 down here. But what we don't have is we don't have this measurement. We don't have the height, right? And we don't have this measurement up here, which would be base 1. So we got a little work to do to find both the height and base 1. And like we did over here on example A, we're going to be adding in a couple lines. I've already drawn one that we're going to add in. I'm going to draw a similar line, actually a congruent line right over here. It's going to make a right angle there. And what you might be realizing is that these two triangles that I've just created are both 30, 60, 90 triangles. Right? They're both 30, 60, 90 triangles. So we can use some of those rules that we've already learned about 30, 60, 90s to figure out the missing two sides of these 30, 60, 90 triangles. We have the hypotenuse, which is 4. And since we know the hypotenuse is equal to 2 times the short leg, this right over here, hope you don't get confused with the two H's that I've used. We realize that they stand for two different things in this problem. This H stood for hypotenuse. This one is going to stand for height. But this side right here, which is going to be the height of our trapezoid, it's actually the short side of this 30, 60, 90. So if my hypotenuse is 4, then my height of my triangle, or this short side right here, is going to be a 2. So that's 2 right there, which would also mean that this is 2 over here. Now we're stuck trying to find base 1. And what we're going to do is we're going to use the third side of our 30, 60, 90. We know that that's the long side, and the long side is going to be the short side times the square root of 3. So it's going to be 2 square root 3. So from here to here is 2 square root 3. And that would mean the same thing is going to happen right here. This is 2 square root 3. Now if this whole segment is 12 units long, but these end parts of it are 2 square root 3, we can take the two square root 3's off of 12 to get what this part is just from right here to right here, right? And that distance right here would be the same as the length of base 1 up here. So we're going to say that base 1 is equal to 12 minus 2 times 2 square root 3 is how I'm going to write that. Now I'm just going to go ahead and convert this into a fraction. You could deal with this with the radical and you could leave it like that. But I'm going to convert this to a fraction, to a decimal by using my calculator. So I'm going to say 12 minus 2 times 2 square root 3. And my calculator tells me that's going to be about 5.1. So base 1 is going to be about 5.1. 12 minus 2 times the square root of 12 minus 2 times the square root of 3 gives me about 5.1. So now I can use my formula. Area equals half of the height, which is 2, times base 1, which is about 5.1, plus base 2, which is equal to 12. So now that's half of 2 times 17.1. Well, half of 2 is just 1. So 1 times 17.1, that's going to be 17.1. So there's your area for example B. Okay, folks, good luck on any kind of homework problems that you're going to be working on, and we will see you in the next video.